is to explore what parabolas sort of look like. And by parabola, what I mean is anything that flies through the air on the Earth, actually, not just on the Earth, on any planet, on any moon. Anytime you're on a planet, things will do this. They might do it a little differently, but it'll be the same. But anytime you're moving around on a planet and you're flying through the air, your shape will be a parabola. So, how do we manage this? This isn't exactly the situation in the Jose Bautista home run, but it's close. It says, a major league batter smashes a pitch towards left field fence, which is 10 feet high and 350 meters from home plate. That's pretty close to the dimensions at Rogers Center. Not exactly, but pretty close. Complete each table and graph to show the height of the ball as a function of time and then as horizontal distance traveled. Well, you don't have to know what all that means just yet. The facts are, they gave us this, the equation of the parabola. I want you to notice one big difference with these equations than last chapter. The squared there. Do you see the squared there? That's what's different this chapter. So it changes the way you type it into your calculator, but I'm going to show you how. So grab a calculator. If you don't have one, grab one. You're going to want to type this in. I've got my calculator on the screen, which might not be exactly like yours, and that's okay. We can use slightly different calculators, but see what the calculator can do. This one says to find the height, negative 16t squared plus 64t plus 4. It starts with t equals 0. So type in with me. Negative, find your negative button, 16. Now I'm going to sub in the t. The first t I've got is 0, so I put that in there, 0. Then squared. Some calculators have a squared button. Mine does on my screen. It literally has a little picture of x squared, and that's what you push, and you can make things squared. Does yours have a squared button? Yes. Yeah, so that makes it easy if you have a squared button. If you don't, just call me over, and I'll show you what to do on your calculator to do it. Next, plus 64, and I'm subbing in 0, plus 4. Does anyone know what the answer is before I even press equals? 4. All those zeros, it was sort of a waste of time. So when I press equals, I get answer 4. Did you get answer 4? Yeah? Did you get 4? Yeah? Good. So now, then they said do it for 0.5. Now, listen. At that point, you might be like, oh, got to type this all in again. No, most calculators, you don't have to type it all in again. If you just hit the left arrow key, watch this. You can just arrow over, and those zeros, I can change them to 0.5, making this 1,000 times easier than retyping it all in. And then I go over to here and change that 0 to 0.5. Does your calculator act a little differently than mine? Maybe. Maybe you got to play around with yours to get it to go on the screen like that. But you can put in 0.5s instead of zeros. That's good. What do you get? 32. 32. Let me see if I get the same as you. 32. If you're not getting that number, don't freak out. Just call me over, and I'll look at how you're typing in. It's just a matter of knowing how to type it in the calculator. So, I'm not going to graph it yet, but and I'm going to pretend like it's the Jose Bautista video that we just watched. First hit the ball at a height of 4 feet. After half a second, it's already up to 32 feet. Does that seem like a lot? If you've ever been to a Blue Jays game, you'd probably decide that that is not a lot for it to go up. They hit them hard. It's unbelievable when you see them actually hit one. So next, I want to change that to 1.0. That's a little more difficult. Here, watch on mine. Mine's got a backspace button. Maybe yours has a delete. I'm going to go back and backspace over those and change it to 1.0. Do I need the 0.0? No, probably not. But I'm putting it in there because that's what it says, so I'm going to do it. And then this one, I change it to 1.0. Is it possible you'll mess up and have to retype the whole thing in? Yeah, that can happen too. But you can just go back and change those all to ones and then press equals again. The calculator's friendly like that. It allows you to go back and edit what you wrote and retype it in. What did you get when did you type it in? Listen, if you're at the point where you can't even be bothered to get a calculator and try typing this in, then I don't know what to tell you, okay? Get a calculator and try typing this in. You're like, oh, it's so easy. It's mostly easy, but you got to try it out to make sure you know how to get the calculator to do it. I get answer 52. Did anyone else get 52? Shamar's agreeing. Good. Next. Now it wants 1.5. This sort of gets repetitive. You arrow back over. On mine, I use backspace. Yours might be delete, D-E-L. I'm going to delete the 0.0 and change it to a 0.5. I'm going to go over here and delete the 0.0, change it to a 0.5. And when I'm done, I get 64. Do you get 64 in the next one? Anyone else get 64? If you're having trouble, just call me over. I'm not trying to rush it. But if you get used to how to type this in, it doesn't take all that long to put them in. What's the next one? Change those 1.5s to 2.0s. Go over, backspace over the 1.5. If you accidentally backspace over the bracket, then you just have to put the bracket back in, no problem. Backspace over this till I can put in 2.0. Make sure my bracket's there. Equals, I get 68. Then do it again. Try it yourself to see if you're getting the same as me. Do it again for 22.5. Some of you are probably a little behind as you're getting used to typing your calculator. Some of you might be ahead. You might go, oh, I'm even faster than he is. Yeah, good. 64. Ooh, what happened? What's happening here on the height? It got to its highest. After 2 seconds, it was already at its highest point. Is that realistic? I don't actually know how long in my head, how long these things take. But for the sake of this one, it goes up to a height of 68, and now it's starting to come back down again. Now change it to 3.0. You get it now? It goes up, and then it starts to come back down again. I need to tell you, folks, this equation, if you saw the actual equation the broadcasts use on baseball to calculate these things, it would be really close to this. This is almost all you need to calculate how far baseballs will go. Oh, some people are discovering something interesting about parabolas. Parabolas are what we call symmetric. They go up, and then they come down the same on either side. Yeah? I don't want to jump too far ahead, but if something has a lot of air resistance, it might drop down faster if there's a lot of air resistance. But baseballs generally follow this pretty closely. What do you suppose the next one's going to be? Yeah, can you already sort of predict what's going to happen here? Oh, I messed up. Did you see me mess up? I did the wrong backspace thing, so I'm going to have to fix mine up. And that's going to happen sometimes too. Don't be surprised if you make a mistake and have to change things around. The calculator is not a perfect device for typing these things in, but it's pretty good. 32. The last one you think is 4. I agree. I think that it should be 4. But I'm going to type it in just to show the typing in, especially if you're back looking at this video later, or if, for somebody who was away, then they need to go back over this and type these all in. By the way, this is really difficult to do on the calculator that comes with your phone. If you're trying to type these in on your phone, oh boy, it is tough to type in. So if all you've got is your phone, you may want to download an app that has a better calculator on it. The calculator built into the phone is not very good. And I got 4. All right. Now, get ready for something that might be slightly different than graphing last chapter. Phone's away. When I go to graph 0, 4, do you see how 4 is not right on there? you're going to have to sort of estimate and go, well, 4 is about there, not quite halfway up to 10. And 0.5, when I'm looking for 32, that's just above 0.5. So graphing, sometimes you just have to estimate and say, well, about there. That's about the right spot. 1, I was up to 52. 1.5, I'm up to 64. 2, I'm up to 68. But that's the highest one. And then it starts to come down again on the other side. 2.5, 64. 3.0, 52. 3.5, 32. And 4 back down to 4. Now, someone just asked about a ruler. This chapter, you won't need a ruler. It's not a straight line. What you got to do, and look at me warming up here to get this, is you got to draw a curve through those points. Here's what the ball does. Look at my tongues out as I try and do this. D, 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 D. That's what the ball looks like as it goes through the air. Well, typing it the first time is a lot of typing. Then modifying it, it's not quite, it's not bad.
Could you only type it, for this one, only 2 seconds?
Oh, yeah. Part of what we're going to do this chapter is find out that once I've got one side, maybe I can just do the other side. I don't got to type them all in. But today we're just learning about them, so we're going to go through the procedure so we see what's happening, okay? Now, this might be hard to understand, but that's a graph of time versus height. That's technically not what the ball looks like going through the air. The ball through the air looks like this next one. Okay, do you need more time on that one? You got that one okay? More time? More time? Okay. The ball through the air is going to look differently than that. This is correct, and it is a parabola. Oh, do they? That's going to be a challenge. That's going to be a challenge. I don't know what I'm going to do about that. I'll have to go down when I finish here. Isla?
Hi.
Welcome back. But sheets. Oh, Chris, here you go.
What's this?
This is what we're working on. All right. Now we're going to go again, but this one actually will look like, because this one's versus distance, versus how far it's moving across the baseball field. So a slightly different equation for this situation. But very similar typing in. Here I go. Get your calculator out. Try it now so you can find out how to do this. Negative 0.0, oops, I've already making a mistake there. 0.002, 0, look for your squared button, plus 0.72, and if you're getting annoyed by typing this all in, that's okay. You got a fancy calculator there. Do you get 4 as the first one? You're less than surprised. Whether we do time or whether we do distance, both start at 4. But this is different. It's not asking where is the ball after 0.5 seconds. It's saying where is it after 50 feet. So this might be the second baseman asking how high is the ball when it gets out to me at second base. Is second base 50 feet away? Let me think for a second. 90 out to first base. No, probably more like 100 out to second base. So when it's about even with the pitcher, how high is it? Not based on time, based on how far the ball has gone from home plate. Okay? So let's type that in. Oh, don't retype it all in. Go back and change the 0 to 0.5. No, to 50. Whoa, not 0.5. That was the other one. 50. Just a second. Let me just type this in for anyone who's with me on that, and then I'll answer questions. Yes, question. Change those all to 50. So where's this ball after 50 feet? It's heading out towards the second baseman. What do you get?
35.
It's 35 feet in the air. That's why the second baseman isn't going to be able to catch it. It's way over his head. Now change it to 100 feet. And it's a little messing around, but you don't have to retype the whole thing in. Mine, I backspace and I change it to 100. Yep, those are both hundreds. And so I got 56. So at 100 feet, which is probably close to where the second baseman would be standing, it's now 56 feet in the air. And if you've ever played baseball, this isn't hard to do with a second baseman. Nothing they can do. They just look up and they go, oh yeah, there it goes. Is it going to go out or not, though? Now 150. So go back and change those hundreds to 150s. Not 1500s. 150. Type it in, try it out, see what you get. 67. So 150 feet, where's that? That's like almost, it's past second base, almost to where the right fielder might be, but not quite. Yeah, not quite that far yet. Right fielder might start at about 220. It's about maybe where they might play it in the major leagues. Yeah. Now 200. Where is it as it's about to get where the left fielder might be standing? You get 68? So it's got up to its highest point. I don't know exactly where, close to where the left fielder is. And what do you think's coming next? I don't know. Let's type it in and find out. 250. 250. 59. It's on its way back down. Then 300. Okay, 300 is getting close to the wall now. $40, it's down to. It's coming down. Now 350, only 2 more to go, yes? What's that? Yes and no. Yes and no. Let's talk about what that means in just a second. Actually, I'll graph it first, and we'll decide what that could possibly mean. Does the negative make sense for realsies? No. But it does tell us something about what just happened. Negative 28. A shocking result. Let's not overthink it until we graph it, though, okay?
On the other graphs, like when you got the half, like every, like, and when they got half, it was the exact same.
I know. And so we got to talk about why that happened there and it didn't happen here. And the answer is it does happen here, but it might not be at a whole number. Because the world doesn't care about us in whole numbers. It might be a decimal, or it might be between 150 and 200 or something like that. So let's try and graph these. 0, 4, 50, 35, 100, 56, right about there. 150, now 67, right about there. 200, comma 68, that's a little higher. And then 250 all the way down to 59. 300 down to 40. 350 down to 11. And I'm going to pretend to graph it, even though I know it's ridiculous. So we can talk about what it means. 400, negative 28, I don't know, down there somewhere. Clearly a baseball cannot do that. Has anyone been to Wonderland, to that new roller coaster? What's the new one called that goes underneath the ground? The Yukon Striker. If this was the Yukon Striker, we'd know what negative 28 means, right? It goes negative 28 under the ground. So maybe negative 28. Yeah, I'll be down in a minute. I'm just going to finish this example, then I'll come down. Okay.
Yeah, I think it's that's what it was you, but in real life, it just bounced.
Oops. Okay. If we're not on the Yukon Striker, what actually happens after the 350-foot mark?
It just like bounces.
Yeah, it'll bounce or hit the ground. Total different equations for bouncing. These parabolas will only cover while it's in the air. Once it hits the ground, that's it. So you don't have to put an X there, but I'm going to put an X there just to go. And that would be the end of our equation. That would be as much as the equation can cover. Unless you were on the Yukon Striker and you could go underneath the ground. Yeah? Now, someone said, why didn't it do the same as the other one? And it does, but look at the numbers that it repeats around is like 160 or something like that. So that doesn't work well with my table. But I didn't know that going in. So sometimes we'll know that and sometimes we won't. The other table was set up very nicely. Okay. Wait. Actually, I'm going to trust you for a minute. I'm going to go down. There's going to be a pause in the video. I'm going to put my microphone there. Don't say anything crazy. Will you keep an eye on that? While I go down and talk to the people in the Learning Center real quick, and then I'll go back. You got time to?
It's fine.
You got time to copy this? I'll be right back. Sorry about that. Somebody need a little helping hand there. Any questions about these parabolas? Remember, we're just learning about them right now. We're just at this point, it's just like, okay, a parabola is a curve. Oh. And I got to know about squareds. I got to be able to press squared in my calculator. Okay, which of the two graphs shows the flight of the path of the ball? The second one. It actually shows the same thing we saw in the Jose Bautista video. When you're watching on television and watching a baseball fly through the air, that's what this one is. Distance and height, those two things going on. So that's a realistic look at what baseballs look like. What graph would be the same even if the ball were hit straight up? The first one. It's only based on time. So it looks the same whether the ball was hit out of the park or just straight up and down. Have you ever seen a fly ball like that goes straight up in the air and the catcher catches it? That first graph would look the same. It still goes up and comes back down. How about what was the height of the ball when it was hit? I'm going to start doing these questions down here because they're not fitting in very well. What was the height of the ball when it was hit? 4. You can see that in the chart. It's the very first thing on the chart, 4 feet. What is the meaning or significance of the vertex? What is a vertex? Oh, well, that's what I got. Hey, that's what I'm really here to tell you about today. This point right there. That's called the vertex. Have you heard that word before, vertex? Yeah, you might not have. You might not have, but you might have heard. The highest point. Yeah, it's perfect. Okay, so let me get it on here as well. To me, it looks like it's about there. You can disagree with how you draw your curve and say, well, I think it's a little left or right of there. That's okay. But we say it's the highest point. Highest point. Now the big question. The left field fence is 10 feet high and 350 from home plate. Do you think it was a home run or not? Did it go over the wall?
Yes. Actually, no.
Well, at 350 it was 11 feet. Is it enough to go over the wall? That's what the question says. It says if the left field fence is 10 feet high and 350 meters from, so it's just enough. One foot over. Now, if you watch baseball, you're like, oh, maybe the guy could be there and jump up and catch it. If he can jump 11 feet, no, he doesn't need to jump 11 feet. He can probably reach 8 feet. If he could jump 3 feet high, I don't know. Could he? Maybe. I don't know. But it looks like it's going to make it by 1 foot. Okay? I have only one more slide for you. All right, you got one more. I got one page I got to fill in. It's just some labels of the names we're going to use for the things, for the features Are you ready for the last page? Wait. Good? All right. So introducing the parabola. This curve that we're talking about is given a fancy name called the parabola. You see them out in the world all the time. These satellite dishes are actually built in the shape of a paraboloid, it's called. It's a parabola in every direction. Many structures are built like parabolas, and this is the path of a basketball. Anything that flies through the air is going to follow some kind of parabola. What? Yes?
So is this stuff with the advanced functions?
Yeah, if you look on the board, they're actually looking at, here's one that is a parabola for a while and then switches, and then this one has a parabola connected to another parabola. It's technically not a parabola, but it really is very close to that looking. And if you look on the sideboard, the grade 11s right now are working on equations that have squared in them. These are parabolas too. So a lot of stuff going on with parabolas. Yes, one individual wave might look like a parabola. The problem with waves is often then they have a low part too, so it goes back and forth like that. So we'll come up with a different function for those, but yeah, each of those waves looks like a little parabola and can be modeled like that. Okay, here's my labels of everything you need on this diagram. Let me look at your diagram to make sure. Oh, you've already got the nice labels on there. Okay. So this one here, that's called an x-intercept. I'm hoping that's a little familiar. When I say x-intercept, I hope you're like, oh yeah, I sort of remember. We were talking about x-intercepts before. That one over there and this one over here are called x-intercepts. Notice this one has 2. The next thing you might have on your parabola right there, what do you suppose this one's called? That's the y-intercept. Good. Again, that sort of is familiar from last chapter. This is new, this point right here. I just gave it a name. Let's see if somebody can remember the name already. Yeah, in this case, how low, right? So, yeah, but let's not get bent out of shape by that. But that highest or lowest points, I've given it a new name. Vertex. So the vertex can be that highest or it can be the lowest point. I don't want to forget anything, so I got my little sheet here. And this thing here, I like writing it sideways because I think it's fun. This thing is called the axis of symmetry. And it's the line that the parabolas looks the same on the left as it does on the right. We saw that in the example. It went up and then it went down. And when it switches over there, that's called axis of symmetry. You don't have to write it sideways. I just did that because I think it's fun to do. I got my notes here so I don't forget to tell you anything about it that you're going to need. So, I hope that 3 of those 5 names, you're like, oh, that's not bad. And then 2 are sort of new. The vertex and the axis of symmetry, those are new words. But you've got your reference sheet now you can look at anytime you need to use those words. Or if the question uses the words, you can look back at the picture. I know the homework's like that. It says, oh, the axis of symmetry is this. Then you can look back at the picture and figure out where that is. And I got some notes to tell you about each of these things. Nothing too crazy here. Oops, that's not the page I want. I want this page. Whoops, this one. X-intercept. Where the parabola hits the x-axis. I hope that's not mind-blowing because we talked about x-intercepts last chapter. There can be 2, 1, or 0. We might not get any x-intercepts here. Depending on where the parabola is, maybe it never hits the x-axis. The y value will be 0. That's another way of saying an x-intercept is where the y value is 0. And the last thing I want to say is these are also called zeros. Sometimes we call them x-intercepts. Sometimes we call them zeros. Y-intercept, not too exciting. Where the parabola hits the y-axis. There is only one. There will only be one. And the x value will be 0. Again, I don't know that x and y intercepts are going to upset you too much. We have some experience there. Vertex. Okay, someone already used, I think Joseph said what the vertex is. He didn't know the new word or anything, but he says, oh, that's the highest or lowest. That's what the vertex is. It's that highest or lowest point. You can also call it the turning point. We found that in the example. That was where it's switched from going up to down. And it's on the axis of symmetry. This weird line that divides a parabola in half. Which I'll do that definition as well. Is it scrolled down for me, or do I have to switch pages? It's all on one page for you, isn't it? Oh, I've got to switch pages, so I got to wait for you to be done there.
It's 4 points on the vertex.
Yeah, I know on the vertex there's a fourth point there. Write it as a point. Like you'll have an x and a y. So when we ask for the vertex, we want the coordinate of the vertex. I'm glad you asked about that. I'm glad I wrote that because I almost forgot that when you write it, you want to write it using the x and y value, the coordinates of the vertex. Oh boy. All right, we're in the home stretch here. 4 points about axis of symmetry and 2 fun diagrams, and I'm done. How am I doing on time? Yeah, we got off to a slow start today. Ew. Do you need more time there? Yeah, okay, that's okay. In those little breaks is when I used to do attendance. So I'd have it done at the end of the lesson. I can't do that anymore because it would be on the video, and no one wants their picture on the video, do they? Everybody, what? Everybody freak out. Like, don't show my picture.
You actually should. What? And you can rate us.
I could.
Like, no, like,
I can't. Have your mark come up on the screen too? This is Bob. His mark is 65. What, is this Friday? I really apologize I wasn't here yesterday. Well, you'll see. I'm fine. I'm not ill. Yeah. It didn't work out. Life became a train wreck all of a sudden. Not an actual train wreck. It's just a saying. More time? Yes, I'm fine. Axis of symmetry. What did I tell you about the axis of symmetry? A vertical line. Cutting the parabola in half. That was long. That's a long sentence, but I think it's necessary to give you one long sentence about axis of symmetry. It's that line that goes straight down that cuts it in half. When you want to write the axis of symmetry, you write just the x value of it. You say x equals some number. It goes through the vertex. And the last point there is halfway between the zeros. That is going to come up as we go along here, that we can find that max or min by going halfway between the two zeros. And this last thing is direction of opening. There's two kinds of parabolas. Ones that open down and ones that open up. The downward ones make sense, throwing baseballs, throwing footballs. The upward one, you might be like, well, how can you get an upward parabola? And you wouldn't get that from throwing things around. We'll see other situations where it's like, oh, we got a parabola. Maybe a hanging chain. You know, if we each had the end of a chain and it would hang down in between like this. So there are other situations where you can get upward ones, but they don't relate to the baseball thing I did. Jackson.
May I go to the bathroom?
Oh, well, let me just make sure there's no questions here. So, your job, it's just a front and back page, I think. Just a little playing around with parabolas. Just a few little questions about parabolas to see if you understand what's going on with parabolas. So get that done, and I will check it on Monday.